Okay, grade 9s. Today we're going to do a lesson on area. Area is a space inside a closed object. Places you might see area in the real world, it might be carpeting and painting. Formulas for area are given below. There's more than one formula for area. If you're doing a quiz or a test, the formulas will be provided for you. Okay? So, here we have the area of a square. The area of a square is s squared. Okay? Now, what is a square? A square is a four-sided object in which all of the sides are equal, and there's four equal sides, and all the angles are right angles. Okay? And what I'm going to do here, just so we can focus on each one nicely, is I'm going to make a little, that's what I want. Yeah. Okay? Then after that, we'll talk about the rectangle. The rectangle is very similar to the square, except because all of its angles are 90-degree angles. It's a four-sided object, just like the square. The only difference is instead of four equal sides, there's two pairs of equal sides. And as far as knowing which ones are which, you see this side has one tick. Oops, okay, it's not going to let me do that. Okay, so you've got two sides with one tick, two sides with two ticks. The two sides with one tick are equal. The two sides with the two ticks are equal. Okay? So the area of a rectangle is just length times width. And just going back to the square for a second, the area of a square is just s squared. In other words, if you know the side length of a square, just square that number. Moving along, we have the triangle. And the triangle has a base and a height. And the height is found by dropping a perpendicular down to whatever the base is and going up to the highest point on the triangle. The area is half the base times the height. So whatever the base times the height is, take half of that. That's the area of a triangle. Okay? Parallelogram. A parallelogram is like a rectangle. The only difference between a parallelogram and a rectangle is parallelogram doesn't have 90-degree angles. Okay? The parallelogram is like a rectangle that is kind of falling over. And it has a base and a height, just like a triangle, and the parallelogram's area is found by just taking the base times the height. Okay? Now we're going to do the circle. Area of a circle is just pi r squared. So when we're talking about the area of a circle, we don't care about the diameter. We need to know what the radius is, and the area is just pi r squared for a full circle. Okay? Last but not least, we have a trapezoid. A trapezoid is a four-sided object in which there are two parallel sides, and then those two sides are joined to give us four sides. There's a base, there's a height, and then there's an A. Now A is the side that's parallel to the base. So to find the area of a trapezoid, you figure out what A plus B is, take half of that or divide it by 2, and then multiply it by the height. Okay? And that's how you find the area of a trapezoid. Okay, moving on. Example, find the area. So whenever we do a question like this, the first thing we need to do is to identify the shape that we're talking about. So if we take a look at the first one, it's a rectangle. So we know the formula. If we need to look at the formula on our first page of our notes, then let's do that. But we know the formula is going to be length times width. So the area is going to be 14.4 times 2.5. So the area is going to be 28.8 plus 7.2, which should be 36. So it's going to be 36 meters squared. The key difference between perimeter and area is that when we talk about area, we're talking about square units. So it's 36 meters squared. Okay? Now we'll try the triangle here. So we know the area of a triangle is 1/2 base height. So the area of a triangle is 1/2 of 6.8 times 3.3. So if we wanted to do this on our calculator, what we could do is we could figure out what 6.8 times 3.3 is. And we get 22.44. Then we divide that by 2, or multiply it by half, and get 11.2 centimeters. Okay? So that's the area of a triangle, is 11.2 centimeters. Okay, find the area. So it's a circle, so we know the area is pi r squared. The trick to this question is it doesn't give us the radius, it gives us the diameter. The radius is half of the diameter, so the radius is going to be 4.5 centimeters. That's half of 9 centimeters. So we know that when we come to the radius, we're going to plug in 4.5 here, squared, and then we're going to take pi times 4.5 squared. What comes first? Multiplication or exponents? Exponents. So 4.5 squared is 20.25. Now to figure out the area, it's going to be pi times 20.25. So again, to use the pi button on our calculator, we press Shift, and then we press EXP, and then we get that string of numbers on our calculator, 3.141592654. So Shift EXP to press the pi button, and then multiplied by 20.25, and we get 63.6 centimeters. That's the area of the circle if we round it to 1 decimal place. Okay? 1 decimal place is probably going to be good enough for our purposes. Part B. Part B isn't any really real kind of shape that we know. So what can we do with Part B? Well, with Part B, what we can do is we can treat this as 3 rectangles. Rectangle 1, rectangle 2, rectangle 3. Find the area of each of the 3 rectangles and then add them together. Okay? So focusing on this first rectangle first, we have, it's 12 centimeters by 5 centimeters. So 12 centimeters by 5 centimeters. So the area 1, the area of rectangle 1 is going to be 12 times 5, which is 60. Okay? Now, we do the exact same thing for area 2. Okay? So area 2 is going to be this rectangle right here. Problem is that the length and the width are not obvious to us. So what we have to do is we have to look at this 5, this 9, and this 20. Because 20 covers this whole strip here. 5 and 9 cover this. So we know that this piece here is going to add together with the 5 and the 9 to make 20. So 5 and 9 makes how much? It makes 14. So 14 plus what gives us 20? Well, 14 plus 6 gives us 20, so we know that that's 6. Likewise, this whole thing here is 12. We know that this is 7, so that means that this piece right here is going to be 5. So we know that the length and the width of area 2 are going to be 6 and 5. So area 2 is 6 times 5, which is 30. So for area 2, we have to do a little bit of work to figure out what the length and the width were. Now, let's try area 3. We know that this piece here is 9 centimeters. We know that this piece here is 12 centimeters. So area 3 is 9 times 12, which is 108. If we add these all together, we're going to get 198 centimeters squared. And that's the area of the whole composite object. This is not a parallelogram, a circle, a square, a rectangle. This is a composite object because it's made of two or more objects that we know. It's made up of 3 rectangles. So we have to find the area of each of the rectangles, then add them together to find the total area of the entire object. Okay? Okay. 2 more examples. Find the area. We have a rectangle, this is another composite object, plus a half circle on the end. How are we going to find the area of this? Well, again, we're going to worry about this piece first and this piece first. So the area 1 is a rectangle, so it's length times width. So that's 6.6 times 8, which is going to be, I don't know. What's that going to be? Well, that's going to be 13.2 times 4. So that's 52.8. So it's going to be 52.8. And then we're going to find area 2. Now, area 2 is sneaky because it's not a whole circle. It's a half circle. So how are we going to do that? Well, the formula for the area of a whole circle is pi r squared. But because it's a half circle, we can divide it by 2. So pi. Now, what's the radius? Well, this whole thing is 6.6. So that means that the radius is half of that. It's going to be 3.3. So we have to divide that by 2 to get the radius. So it's going to be 3.3 squared divided by 2. So now what we're going to do is we're going to figure out what this is. So to do this, we're going to do 3.3 squared first. We get 10.89, so we get pi times 10.89 divided by 2. Now to figure out this, we might as well divide 10.89 divided by 2, and we get, I'm going to give myself a little bit more room here. That's going to be pi times 5.445. I'm writing out as many decimal places as I can while I do the question. The final answer we will round to 1 decimal place. So I'm going to take 5.445 and multiply it by pi. So again, to use the pi button on my calculator, I press Shift EXP and then multiply it by 5.445, and I get 17.1 millimeters squared if I round to 1 decimal place. Now, that's just area 2. To find the area of the whole thing, I'm going to take area 1 and add it to area 2. So that's going to give us 52.8 plus 17.1, which gives me 69.9 millimeters squared. That's my answer. And I get that by adding those areas together. Okay? Last example. Find a shaded area. So what I'm really trying to do is I'm trying to find that yellow area. I'm not trying to find the area of the circle. I'm not trying to find the area of the square. But I'm going to use the area of the circle, and I'm going to use the area of the square to help me find that shaded area. How will I do that? Well, basically, here's what I need to do. I need to find the area of the square and subtract the area of the circle. And the space that's left over is the shaded space between the two objects. So the area of the square is just going to be 10 squared. The area of the circle is going to be pi times the radius squared. Now the radius isn't going to be 10 because that's the diameter. It's going to be half of that. So it's going to be 5. So it's going to be 5 squared. So 10 squared is 100. 5 squared is 25 times pi. So again, I'm going to use that pi button on my calculator. So shift pi times 25 is going to give me 78 point. Now I could probably do this to one decimal place at this point because it's right by the answer. So 78.5. So if I subtract that from 100, I'm going to get 21.5 centimeters squared. That's my area of the shaded area that's in yellow in the diagram. So I found the area of the square, then I subtracted the area of the circle, and what was left over was that shaded area.